Hello, this is your special education virtual content specialist with the 8th grade math lesson for June 25th. This lesson, like all lessons, can be found on TeachHub, and we provide the title, the focus question, and the learning objective, including the standards and objectives for each lesson. Additionally, we provide guidance for using this resource, including instructional and technology guidance, implementation guidance for the lessons, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging multilingual learners and students with disabilities. 8th graders are working on Unit 9, putting it all together. Day 11, tessellations of the plane. When can a pentagon be used to form a tessellation on a plane? Remember that this lesson is a part of a 7-part series that will give you the opportunity to explore geometric patterns. Each of the 7 lessons will build on each other, so you may want to refer back to earlier lessons as you go. Make sure to keep a copy of the work you do today so you can refer back to it later. The introduction provides students with 2 images, and they are asked to write down what they notice and what they wonder. To support students with disabilities, you can give them bullet points so they know where to write their answers, and to keep their answers for their noticings in the noticings box and their wonderings in the wondering box. A sample response could be, I noticed that the blue pentagon is a whole shape. I noticed that the green shape is a square with a triangle on top. Some wonderings may include, I wonder if the pentagon can tessellate. I wonder if the green square and the green triangle can tessellate. Students are asked, do you think the pentagon to the left can be used to make a tessellation? If yes, what do you think it would look like? If no, why not? To support students with disabilities, you can provide them a sentence frame, such as the one seen here. I think it blank, so can or cannot, be used because blank. Students should respond, I think it cannot be used in the shape that it is currently given. Students are provided with a new image, and they are asked, do you think the pentagon to the left can be used to make a tessellation? Once again, they're asked, if yes, what do you think it would look like? If no, why not? Again, provide students with disabilities with a sentence frame. Students can say that this square base with a 45-45-90 triangle on top could possibly be used to tessellate. The explorer asked students, can you tessellate the plane with copies of the pentagon? Explain. Note that the 2 sides making angle A are congruent. So students should realize that they can tessellate with this particular pentagon because they can make a hexagon from 3 of these pentagons and then tessellate the plane with those hexagons. On this slide, students are asked, Kimonique began her tessellation pattern as shown. What type of shape do these 3 pentagons combine to make? How do you know for sure? A sample response would be the 3 pentagons combine to make a hexagon, and we know because 3 of the 6 sides of the hexagon are corresponding sides of the pentagon after a rotation. For the other 3 sides, the angles 180 degrees are supplementary, and so the 2 segments making those sides are collinear. All angles of the hexagon measure 120 degrees, so it is a regular hexagon. A misconception that students may have is that they may wonder why the hexagon that they make by putting 3 pentagons together is a regular hexagon. Invite these students to calculate the angles of the hexagon. Students are asked on this slide, can we use this shape to create a tessellation on the plane? How do you know? So you can alternatively ask, does the hexagon made by the 3 copies of the pentagon tessellate the plane? The answer is yes. And how would students know? They can either check experimentally or they can notice that all the angles in the hexagon are 120 degrees. Students are asked on this slide, what about this hexagon shape make a regular tessellation on the plane possible? So students may say that the angles that are joined at the central vertex each measure 120 degrees, and there are 360 degrees in the full circle. Some questions to discuss include, why was it important that the two sides of the pentagon making the 120 degree angles are congruent? So a sample response to that would be, so that when I rotate my pentagon, those two sides match up with each other perfectly. You may also want to ask, what is special about the pentagon? Two sides are congruent and three angles measure 120 degrees. For the summary, students are recording their response to the focus question, when can a pentagon be used to form a tessellation on a plane? For students with disabilities, you can provide them a sentence starter such as this one. A pentagon can be used to form a tessellation on a plane by blank. This lesson, like all lessons, were adapted utilizing illustrative mathematics and open up resources. Please visit these sites to support digital learning. If you have any questions, reach out to your virtual content specialist. Thank you.